Hi everyone, I am Pratima. I welcome you all to this video. So today we will learn probability independent events. Class 12 NCERT will do questions from exercise 13.2. So what are independent events? E and F are two events such that the probability of occurrence of one of them is not affected by occurrence of the other. Such events are called independent events. Two events E and F are said to be independent if EF is given is same as PF, provided probability of E is not 0. Similarly, probability of EF is given is PE, provided PF is not equal to 0. Thus, by definition, we have PF is not equal to 0, PE is not equal to 0, and PF is given is equal to same as PF, and PE condition F is same as PE. Then we know the multiplicative law. By multiplication rule of probability, we can write PE intersection F is equal to PA into PF by E when E and F are independent. Then again I can write E intersection is equal to PE into PF. So I hope you have followed. This is equal to PF. Instead of this, I can write this one. So it is PE into PF. So independence of two events is also defined as follows. Let E and F are two events associated with same random experiment. Then E and F are said to be independent if E intersection F is PE into PF. This is the simple condition for independence of these two events. So two events and E and F are not be dependent when this not equal to P intersection F is not equal to P into PF. So if there are three events A and B and C, they are said to be mutually independent. If A intersection is B is PA into PB, A intersection is PA into PC, B intersection C is PB into PC. So all the intersection will take as PA into PB into PC. So A, B, 3 are mutually independent if this holds good. Now let us learn some more thing about independent events. If A, E and F are independent, events E and F are independent, then we are getting not E or their complements and not F are also independent. Similarly, E and not F, they are also independent. And your not E and F are also independent. So now we can write in that way P E intersection F is equal to P into PF if they are independent. In the same way, I can write P E not E intersection F is equal to P not E into PF, and so on. I can write E intersection not F is equal to PE multiplies P not F, and the last one P not E not F is equal to EF. Next, let us take another concept, that is independent and mutually exclusive. Mutually exclusive. We have read in class 11, but still it is required here. Mutually exclusive means when P probability of E intersection F is equal to 0. PE intersection is equal to 0. Exclusive means there is no common element in E and F, or no common anything, any event. So mutual intersection is 0. Now talking about independent event, for about if we'll say head and tail, they are not independent, they are dependent, because one head is not coming means tail is coming. So probability of head and tail, getting head and tail in one coin, when you are throwing one coin, they are not independent. Not independent. One coin. So when you are throwing two coin, tossing two coins, now getting head in first coin and getting tail in second coin are independent. So let us go for the examples and questions. So question number 1, PA is equal to, this is your exercise 13.2. PA is equal to 3 by 5, PB is equal to 1 by 5. Find PA intersection B if they are independent event. So you will just multiply PA intersection B is equal to PA into PB. So how much it will be? It will be 3 by 5 multiplies your 1 by 5. Answer is 3 by 25. Next, coming to question number 2. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. Both will be black. Okay. That means first event is your getting a black. And second is getting a again black. That means probability of black 1 as well as black 2. They are independent because it does not depend on the first one. So probability of black 1 into probability of black 2. So what is the probability of black 1? Black 1 will be, there will be 26 by 52 cards, so it will be 1 by 2. And it is given that it is without replacement. Without replacement means we have taken one black card. So now there are how many black cards? 25 black cards. And how many total cards? It will be 51 total cards. So what is the probability of black 2? It will be 25 by 51. So what is the answer? Getting both black. Both black will be how much? It will be 1 by 2 into 25 by 51. So it will be 25 by 102. Question number 3. A box of orange is inspected by examining 3 randomly selected oranges drawn without replacement. If all the 3 oranges are good, the box approves for the sale. Otherwise, it is rejected. Find the probability that box contains 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for the sales. Okay. So here I am taking another concept, what you had already read in class 11, that is your application of combination in probability. When you are picking more than one or you're without replacement, you can apply combination. Without replacement. Without replacements, you are taking more than one together. So use combination. Now let us read the question again. So there are how many oranges? 15 oranges are there. Out of that, 12 are good. Now if three are picked, if all the three are good, then it will be approved for the sale. That means there will be probability of all will be 3. So probability of 3 goods, it will be how much? I'll take 3 goods from your goods, 12 combination 2 and combination 3 because I'm taking 3 not 2, and here I'll take 15 combination 3. So that will be 12 factorial by 3 factorial into 9 factorial by 15 factorial in by 3 factorial into your 12 factorial. So it will be 12 into 11 into 10 by 15 into 14 into 30. So how much it will be? You can cancel 5 2, 5 3, 3 4, 2 7, 2 2. So 2 2 4, 4 4 is 16 by your 91. And if you want to use the combination, how you write this question? We'll write first good will be 12 by 15. Next good will be 11 by 14. Why? Because one good already you have chosen and we are not replacing. Similarly, one sample space will be less. The next will be your 10 by 13. So this will be probability of black good 1 combination good good 2 intersection good 3. So this will be probability of good 1 into good 1 into good 1. So this will give you the same answer. 5 2s, 5 3s, 3 4, 4 2, 4 7. It will be your 11 2 times 20 to 12 44. 44 by 91. It would be 11 to 44 by 91. So 44 by 91 is the answer. Let me rub and write nicely. 44 by 91. Next, coming to question number 4. A fair coin and an unbiased die are tossed. One coin, this gives you head and tail, and a die, this gives you 1 2 3 4 5 6. A is the event, head appears on the coin. A is head and B is event, on 3 on the die. Check whether they are independent or not. So when a coin is tossed and die is thrown, so the sample space is equal to your, how much? It will be 12. 2 into 6, 12. Now head is coming in the coin. So what will be A? A is equal to your H1, H2, H3 up to H6. So this is your Na is equal to 6. So what will the probability of A? Probability of A is 1 by 2. 6 by 12. That will be 1 by 2. Next, coming to B. B is getting 3 on the dice. 3 in the dice means it can be H with H. It can be with your tail. So how many? B is only 2. So what will be NB? NB is equal to 2. So what will probability of your B? It will be 2 by 12. That will be 1 by 6. Now we'll go for their intersection. A intersection B. That means it will be head as well as your 3. Head as well as 3, that is only 1. So it will be 1 by 12. Now see whether you are getting PA into PB is equal to 1 by 12 or not. Yes, it will be 1 by 12. So they are independent. Next is question number 7. Given that events A and B are such that PA is equal to half, PA union B is equal to 3 by 5, PB is equal to P, then find whether P, if they are mutually exclusive. For mutually exclusive, P, A union B is equal to PA plus PB, you know, PA plus PB. So you can get it. So this is 3 by 5. P of A is equal to your half. So PB is equal to how much? 3 by 5 minus 1 by 2. So 1 by 10. So small p is equal to 1 by 10 when it is mutually exclusive. Now coming to independent. For independent, you need PA intersection B. So PA plus PB minus PA union B is equal to your PA intersection B. So they are independent. So what will PA intersection be? PA into PB. Now put the value. PA is equal to half, PB is equal to small p, minus union B is equal to 3 by 5. This is half multiplies P. So now solve for P. So P minus P by 2 is equal to 3 by 5 minus half. So it will be your 1 by 10. Or you are getting P by 2 is equal to 1 by 10. Or P is equal to 1 by 5. Next is question number 9. If A and B are two events such that PA is equal to 1 by 4, PB is equal to 1 by 2, PA intersection B is 1 by 8. Find not A, not B. So probability of not A and not B is equal to 1 minus P, A union B. So first get A union B. Probability of A union B is equal to PA plus PB minus P intersection B. This will be 1 by 4 plus 1 by 2 minus 1 by 8. 8 is LCM. 2 plus 4 minus 1. It will be 5 by 8. Then what will be? P not A, not B is equal to 1 minus 5 by 8. That will be 3 by 8. Question number 14, exercise 13.2. Probability of solving specific problem independently by A and B are 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is solved. Exactly one of them solve the problem. So here, this is the question from independent event. So here we should know that when A, B are solving independently, then their complements are also independent. So when a problem is solved, answer, when problem is solved means this is the most important concept here. This is complement of problem is not solved. And when it is not solved, that means it is not solved by both. So it is your not solved by A, not solved by B. So this will be P. If P not A, it will be how much? P not A will be 1 minus PA. So it will be your PA is given to be half. So it will be 1 minus half, half. Similarly, P not B will be how much? It will be 1 minus 1 by 3. That will be 2 by 3. The problem is solved. It will be how much? 1 minus P not A into P not B. So 1 minus 1 by 2 multiplies 2 by 3. That will be 1 minus 1 by 3. 2 by 3 is the answer. This is part 1 answer. Coming to part 2. Part 2 is exactly one of them solved. That means probability of A solving, whereas B is not solving. Then only exactly one. Or B solving, A cannot solve. So this is 2. Again, these two are also independent. That means A and B complement are independent to each other. So PA multiplies P not B. And similarly, this will be B not. So then it will be P is equal to again the multiplication of P not A into PB. So we have got not A not B, no problem. Then we will write only PA is equal to 1 by 2 multiplies P not B is equal to 2 by 3, or P not A is equal to again half and PB is equal to 1 by 3. So answer will be 1 by 3 plus 1 by 6. So 6 is the LCM. It will be 3 by 6. So the answer is half. Question number 16. In a hostel, 60% of the students read Hindi newspaper, 40% read English newspaper, 20% read both Hindi as well as English. A student A selected as random, find the probability that she reads neither Hindi nor English. If she reads Hindi, find the probability she reads English. If she reads English, what is the probability she reads your Hindi? So though it is questions from conditional probability, but it is also relation with independently they are doing. So what we'll write? Now I am writing probability of Hindi newspaper. I am denoting as H. So this is equal to 60 by 100. Similarly, probability of English newspaper is equal to 40 by 100. And when I am writing both, this will be H intersection P is equal to your 20 by 100. And when it is getting this type of things, then it is not an independent event, because you are getting your not the product of these two. Okay, so this is a question from conditional probability, not independent event. Now coming to part 1. Part is neither Hindi nor English. Neither Hindi nor English means this will be a probability of this one. So this is your 1 minus probability of either or. So first you will find probability of either or from the above thing. So how much it will be? P H either English is equal to 60 by 100 plus 40 by 100 minus 20 by 100. So it will be how much? 80 by 100. Then probability of neither Hindi nor English is equal to again 1 minus 80 by 100. That will be 20 by 100 or 20%. Part 1 is completed. Coming to part 2. Part B, sorry, it is part B. It is part A. Part B is if she reads Hindi newspaper, given that he is reading Hindi newspaper, what is the probability of E? So you know the formula for it is E intersection H upon your PH. So what is the intersection? Intersection is your 20%. And what is Hindi? Hindi is your 40%. So what is the answer? The answer is 1 by 2. Similarly, C, the question is what is the probability of Hindi given that he reads English? So this is P, E intersection H by PE. So how much it will be? 20 upon 60. It will be 1 by 3. Now coming to some objective questions asked in different examinations. A and B are two independent events, then they are two independent events. Then what will be P? A given is B. This is simply P A. We have already discussed earlier. So what is the answer? Answer will be C. Now E and F are independent events such that P of E is greater than equal to 0, less than equal to 1. PF is same, greater than equal to 0, less than 1. Then E and FC are complement of if F are independent. So we have already discussed when E and F are independent, then your E and F complement are independent. Then first one is correct, A is correct. Similarly, E complement and F complement are also independent. So B is also correct. Now coming to C. C is P, E, condition F, and P, E condition F condition. This is complement to each other. So this is again sum is 1. So C is also correct. So what is correct? D is correct. All of them. So D is correct. Question number 3. A and B are two independent events. P A is equal to 1 by 2. PB is equal to 1 by 5. Then what is P? A condition B. What is P A condition B? This is your P only. So how much it will be? It will be half. So A is correct. Question number 4. A and B are independent. We are independent event. A is greater than 0, less than 1. B are also greater than 0, less than 1, which is not correct. Which is not correct. When they are independent, are they mutually exclusive? No. So this is not correct. This is not correct. A, B are not mutually exclusive. They are mutually exclusive. This is not correct. Question number 5. A bag contains 5 red, 3 blue balls. 3 balls are thrown at random without replacement. So when the question is without replacement, again will be treated as your independent event 1 by 1 and getting exactly 1 red ball. So here I can use combination. So what will the sample space? Sample space will be, NS will be your 8C3 and selection will be 5 red will be selected, 1 red will be selected and your 2 blue will be selected. So probability of exactly 1 red and 2 blue is equal to your 5C1 into 3C2 upon 8C3. So calculate. 5C1 is 5, 3C2 is also 3. Only here you will calculate 3 factorial, 5 factorial. If we cancel, it will be 8 into 7 into 6. 3 factorial is your 6. So you are getting how much? 15 by 56. 15 by 56 is correct. Question number 6. 3 persons A, B, C fire at a target in turn, starting from A. The probability of hitting the target is 0.4, 0.3, 0.2 respectively. Probability of 2 hits. 2 hits. That means this is your A hits, B hits, 2, C is not hitting. Or A hitting, C hitting, B is not hitting. Or A not hitting, B hitting, and they are independent events, so we can multiply. We have already done this formula. So PA is equal to 0.4 into PB, B is equal to 0.3, and P complement of C will be 0.8. Plus, now P A is equal to 0.4, PC is equal to 0.2, and this will be 0.7. Next is 0.6, 0.3, and 0.2. So go on multiplying. So it will be 0.096. This will be 0.056. And this will be 0.036. Add this, will answer 6668. So it must be the answer. So 0.188 is the answer. Now question number 7. A flashlight has 8 batteries, out of which 3 are dead. If 2 batteries are selected without replacement, the probability of both are dead is 33 by 56, 9 by 64, 1 by 14, 3 by 28. So we'll select probability of your dead, again dead. So yes, it is first dead will be how much? First dead will be how much? It will be 3 by 8. Now when you are not replacing, then total dead remain is 2 and total battery will be 7. So sample space will become less. So it will be how much? You can cancel 2 with 4, 8. So this will be 3 by 28 is the answer. So this is a simple question. Question number 8. A die is thrown. A card is selected at random from deck of 52 playing cards. The probability of getting a even number on die and spade card. That means this is a probability of even number as well as your spade. They are independent. So probability of even multiplies probability of spade. So what is the probability of even number? It will be 3 by 6. What is the probability of spade? Is 13 by 52. There are 13 spade cards. So how much it will be? 13 1, 13 4, and 2. So this will be 1 by 8. So 1 by 8 is the answer. Question number 9. A Smith can solve 80% of the problem given in a book. A Misha can solve 70%. What is the probability that at least one of them will solve the problem? Selected at random from the book. Options are 0.60, 0.06, 0.94, 0.56. So at least the problem is solved. Probability of at least problem is solved is solved is equal to 1 minus problem is not solved. We have discussed similar question once, so you must have noticed that this is a very important concept. So probability of not A not solved means both are not solving. So this will be 1 minus, how much it will be? 80%, so it will be 20 by 100, and this will be a 70%, so it will be how much? Here 30 by 100, because we are getting all not. So this will be 1 minus 0.6. This will be 0.94 is the answer. Then here question number 10. A and B are two independent events. The probability of that both A, B occur 1 by 6. Probability of neither of them occurs is 1 by 3. The probability of occurrence of A. Both occurs means probability of A intersection B, or this is equal to probability of A into B, because they are independent, it is given. That is equal to 1 by 6. And neither of them occurs means your not intersection not. So this is equal to P not A into P not B is equal to 1 by 3. Then you have to get what is PA. So let PA and PB denoted by X and Y. PA I am writing X and PB is equal to Y. Then what I am getting? I am getting X into Y is equal to 1 by 6, one relation. One relation I am getting 1 minus X into 1 minus Y is equal to 1 by 3. So from the second equation I am writing 1 minus X plus Y plus XY is equal to 1 by 3. Or 1 minus X plus Y is equal to XY is 1 by 3 minus 1 by 6. So it will be 1 by 6. So what will be X plus Y? This gives X plus Y is equal to 5 by 6. Now you have to solve by any method to get X. So I am taking X minus Y whole square is equal to X plus Y whole square plus 4XY. So this will be 25 by 36. 4XY is equal to 4 by 6. Now I will simplify. 36 is LCM. 25. Very sorry, it will be subtraction only. So it will be subtraction minus, this is the formula. So minus, it will be your 24. That will be 1 by 36. So this gives you X minus Y is equal to 1 by 6. Now we will simplify. X plus Y is equal to 5 by 6. X minus Y is equal to 1 by 6. You will add them, you will get 2x is equal to 6. 2x is equal to 6 by 6. 1. X is equal to 1 by 2. So x is equal to 1 by 2 is the answer. So x equal to A is equal to 1 by 2. I hope you have enjoyed. Don't forget to subscribe the channel so that you can learn and get a scope to learn more. Like the video and share it so that your friends can learn. Thank you. Have a nice time.